Okay, so the quadratic word problems we're going to work on today are all of the ones that involve a falling object. So as we read through problems 1, 2, 3, and 5, you noticed that they all had a negative 16t squared. You noticed that they were all dealing with height, and they were all dealing with time. So I want to compare those equations to the standard form equation we've been talking about. All of the ones you're looking at had like h of t equals, and then they had a negative 16t squared. And then I'm going to use the bottom one, the number 5 equation. So look at number 5. It has a negative 16t squared in it. And what else does it have? What else is part of that equation? Is it just regular t? Plus 25t? And plus 5. Okay, so if we compare that to y equals ax squared plus bx plus c. Can you see what a is? A is what? The negative 16. B is 25, and C is 5. So these are in standard form. They may not already be ax squared plus bx plus c. So sometimes you might want to rearrange them. If you look at the first one, the bx comes before the ax squared. So there will be times where you want to rearrange it, and there will be times where it really doesn't matter, and you can leave it just the way it is. It just depends on the problem. Okay, we said that this negative 16 is the same because that part of the formula is actually negative 1/2 of gravity. So this is a formula, just like you have volume formulas and area formulas, those kinds of things. So that negative 16 comes from gravity, okay? Then we have this 25t. We haven't talked about that term yet, but the other day, remember when we had the pencils falling or the sticks falling? And so we had negative 16t squared, let me write it down, negative 16t squared plus 100, or plus 64, or plus 144. Where did those numbers come from? The height that they started out at, right. So if the stick, I think, was being dropped out a window and it was 100 feet high. So that's the starting height. So this 5 is going to represent the starting height. What's the negative 16? That's the part of gravity. And then this is the initial height. So the question is, what is this? Where does this thing come into play? So do you remember what was happening with our stick and our pencil? What was the action? It was being dropped, which means it was not given any additional force. They weren't being thrown out the window. They weren't being pushed out the window. They weren't being shot out the window. They were just being dropped. When you have this middle term, do you remember what we called the bx term the other day? Because if you cover up the ax squared, it's just bx plus c, like mx plus b. So we called that the linear term. If you have a linear term, that comes from any additional force that's been given to the object. So we call it the initial velocity. Velocity is, I don't have a great definition of velocity, but in these problems, the way I see the velocity is the force that it's given to begin with. Okay, so if you jump up, you're giving your body some force. This first problem says the height and feet of a bottle rocket is given by this equation where t is the time in seconds, and it says how long will it take for the rocket to return to the ground. So our rocket is being shot up into the air. So what's its initial velocity? 160 t. So that just means it's being given some initial velocity. I'm not going to ask you what's the velocity, but I think it's helpful for you all to know where all of these things come from. Okay, when we read our first question, number 1, it says the height in feet of a bottle rocket is given by this equation where t is the time in seconds. How long will it take for the bottle rocket to return to the ground? And what is the height after 2 seconds? Those are 2 entirely separate questions. So we are going to focus completely on the first question first, and then we'll work on the second. Sometimes I have students who try to bring that second question into the first one, Don't do that. Focus on the first question, which is, how long will it take for the bottle rocket to return to the ground? When it comes to word problems, the first thing you need to do is identify what your variables stand for. And even though they tell you in the problem, it is helpful for you to go ahead and write it down. So I want you to go ahead and write, what does h of t stand for? What's h? It's the height. And what is t? Time. So we're going to be sure we know that first. Then I want you to take a highlighter, and I'm going to highlight height in yellow. And then I'm going to go through the problem, and I'm going to highlight everywhere they talk about height. So it says the height in feet of the bottle rocket is given by, and I'm just going to highlight h of t. I'm not going to highlight the rest of the equation. Where t is the time in seconds. How long? Is that time or height? Time. How long will it take for the rocket to return to the ground? Is the ground height or time? Height. And returning to the ground, what does that mean the height is? 0. So I would take my pen, and underneath that, I would write h equals 0. And then it says, what is the height for the second question? So they're asking for the height. And then it says after 2 seconds, so I'm not going to highlight that. That's time. So we've identified everywhere they talk about height, and now we're going to identify everywhere they talk about time. So I'm going to highlight time in blue. It says the height in feet of a bottle rocket is given by h of t equals, and then I'm going to highlight my t's in that equation. That's where time is. So if they were to give me the time, that's where I would plug it in. That's where time goes. So if I wanted to know where it was after 1 second, I would plug in a 1 for time. And it says where t is the time in seconds. How long will it take? We said how long means they're looking for a time. Will it take for the rocket to return to the ground? What is the height? And then after 2 seconds. So this highlighting and writing things down has forced me to read the question now 3 times. That's beneficial for us. We have a tendency to read a question 1 time and try to jump in. And if we don't know exactly what to do, sometimes we just don't do anything. We just say, I don't get it, and we stop. So reading it through 3 times is, first of all, helpful. Now let's go to the question part of it. The very first question said, how long will it take for the rocket to return to the ground? So if my equation is h of t equals 160t minus 16t squared. When they say how long will it take, what are they asking me to find? The time. The time. So t should be my variable. So if I'm looking for time, they needed to give me my other variable, which is height. Did they tell me in that question what the height is? Yes. Yes, 0. So at this point, I'm either going to plug in for the height or the time. And since they gave me height, I'm going to plug in for the height. So 0 equals 160t minus 16t squared. At this point, we need to figure out how to solve it. You are not going to use the very same process on all of these problems. They're going to be different. So you have to stop and look at it. Is this equation a linear equation or a quadratic equation? It's a quadratic because we have a t squared. To solve quadratics, the only thing we've done so far, there are a lot of methods. We've only learned one. And that's to get it equal to 0 and factor it. Is it already equal to 0? Yes. Yes. And so now we need to factor it. First step of factoring is there a common factor? Yes. What is it? 16 what? 16t. So you can do one of 2 things. We did a lot of rearranging, right? We put on most of our problems, we put the negative 16t squared first and worked from there. I'll tell you on this one, it doesn't really matter. Just because there's only 2 terms. So I'm just going to go ahead and factor out the 16t. So 0 equals 16t. That would leave us with 10 minus t. So when we're using factoring to solve, once we have it factored, we use the zero product property to figure out what values of t make it work. I'm running out of space here. I'm just going to skip over here. So I would set 16t equal to 0, and I would set 10 minus t equal to 0. And I solve each of those little linear equations. Once you've solved them, you have to figure out what you did and what you found. And one of the good ways to do that is to identify what the units are for your variable. So t was a measure of time, and what was time measured in for this? Seconds. So underneath each one of these, I'm going to go ahead and write seconds. Now, back in the old days, in 3rd grade, once you found an answer, you were pretty much done. But the math problems get a little more complicated, right? Just kind of like life. And so we have to go back to the question and say, what did the question ask us? It said, how long will it take for the rocket to return to the ground? So why did we get 2 different numbers? It's quadratic, which often gives us 2 answers. Where does the bottle rocket start out? At what height? Sorry. At 160 is the initial velocity, but where is the rocket when it starts? It's on the ground. So at 0 seconds, the rocket is on the ground. Then the rocket is on the ground again at 10 seconds. So how long was it in the air? 10 seconds. So we got 2 answers because it was on the ground 2 times. It was on the ground in the beginning, and then it was on the ground again. There's not always 2 answers because things don't always start out on the ground, right? We've done problems where we have like a diver jumping off a diving board. And so you're going to start out above the water, and then they go up and come back down. So there won't always be 2 answers. Yes. Time. Yes, we had one where the pencil was falling out of the window and we said it took 2 seconds, but we also got negative 2 seconds, and that didn't make sense. So then we want to write our answer in a complete sentence because I want to know that you not only know how to do the math, but the bigger part of it is, can you explain what you figured out? So you want to give me a complete sentence?
Oh, no,
Okay.
Or is that like after?
That'll be after. So this is the end of this question. Yes.
Awesome.
Okay. So a complete sentence might be, it takes the bottle rocket 10 seconds to return to the ground. Okay, so now that we found it takes 10 seconds to return to the ground, now we can start answering the second question. The second question said, what is the height? So we're looking for h after 2 seconds. So when we're looking at our formula this time, did they give us height or time? They gave us time. So we're going to plug in our 2 seconds everywhere we see time. So I'm going to go ahead and say h of 2, because that's how many seconds it is, equals 160 times 2 minus 16 times 2 squared. Please be sure and put a multiplication sign in there to help you remember that you have to square the 2 before you multiply, times negative 16. So h of 2 equals 320 minus 16 times 4 is 64. This is a good math fact for you to memorize. 4 times 16 is 64. I'm just going to tell you it comes up a lot in math because 64 is not only a perfect square because it's 8 times 8, it's also a perfect cube because it's 4 times 4 times 4. So you're going to see the numbers 16 and 4 and 64 kind of more often than you see other numbers. So it's worth memorizing just that one little fact to make some of your computations faster. So h of 2 equals 200, what? 200 what, 50 something? 56? Is that right?
No, it would be like 40, 60. Yeah, 256. Yes, that's right.
Okay, yes.
Yeah, it is 256.
All right. So 256 what? Is this a height or a time? Height, because it's h equals, so it's feet. 320 minus 60 is 260. And then minus 4. That's all right, I'm with you. When we're doing it in our heads, we make all kinds of errors. So 256 feet. Again, you're going to write your answer in a complete sentence. So what did we just find out? We found out that it takes 2 seconds
To reach
256 feet. Or at 2 seconds, the rocket's at 256 feet. After 2 seconds, the rocket has reached a height of 256 feet. There are several different ways to word that. I just want you to be sure you talk about the height and the time of the rocket itself. And you use the word rocket. You don't use a pronoun. Don't say it. It what? We're only talking about a rocket. So let's talk about the rocket. Okay, what I want to do now is I want us to use our graphing calculators to look at how this appears on your graphing calculator. So go ahead and get that out. The first thing we're going to do is go to y equals, and we're going to plug in the original equation. This is where people sometimes make mistakes. They go ahead and plug it in with other numbers substituted into it. You want the very original equation that they gave you, the h of t equals 160t. We're going to have to use x just because that's the way the calculator works. So 160x minus 16x squared. We'll plug it in just the way that it is. And then when we want to see the graph, we hit the graph button. The problem is when you do that, you're not going to see a very good picture because we need to change the window. We talked last class about the window only shows you that space. So we want to talk about when we hit the window button, what is a reasonable x minimum and maximum? So that you will see questions that say, what's the domain for this function? So domain is x's. Well, what variable in our equation is representing the x? T. So time is our x value. So what's our minimum value of time? 0. What is the maximum value of time for this problem? For this one? Well, for that piece, we were looking at that one. But when did it hit the ground again? 10. So I'm going to go a little higher than 10. I don't like it to be right on the edge of my graph. And you don't always know those numbers up front. Sometimes you just have to guess what would it be. Would it be 5 seconds? Would it be 10 seconds? I will tell you with falling object problems, it doesn't generally take them all that long to hit the ground again. So I'm going to say 0 for my minimum. And then I'm going to say 15 for my maximum. You could say 12, just something a little bit bigger than 10. The y minimum, so our y for this is height. So what's the minimum height? 0. So you could leave it at -10 if you wanted, or you could go ahead and change it to 0. Kind of depends on what we're looking for. And then the maximum height. So we know at 2 seconds, how high is it? 256. But it doesn't hit the ground for another 10 seconds. I mean, another 8 more seconds. So, you think it?
Because that's 10 seconds.
No.
Oh, but
It's not linear. So something like, I don't know, 500, maybe let's double it and see if that helps. If that's completely wrong, we can come back and change it. I haven't graphed this one, so I don't know. I'm just guessing. What might it be? Perfect. That's really nice. And we can see the whole thing. Yes. So something is important here. I want you to understand that this is not the path of the rocket. The rocket shoots straight up in the air and it falls back down. In order for it to be the path of the rocket, we would need vertical distance and horizontal distance. But we have vertical distance and time. So this isn't the path of the rocket, but it certainly looks like it could be, right? Because that's what it might look like if it's shot at an angle. Okay. Okay, so we've got our graph. We can see what's happening. A couple of different things we can do here. Do you remember when we were looking for all the factors? Do you remember what button we hit?
Oh, yes.
That was the next one over. It was the table. So if you hit second and the graph button, it'll bring up the table. And this will tell you all of the values for your function. If you plug in 1, you get 144. If you plug in 2, you get 256. So it's telling you after 1 second, how high is the rocket? 144 feet. After 2 seconds, the rocket is 256. So when does it hit its maximum and start coming back down? After 5 seconds, it starts coming back down, doesn't it?
After 400 feet?
So that's what it looks like. Can we find the maximum using our calculator? Yes, so go back to the graph. And our keystrokes, we want to calculate the maximum. So you're going to go second and then hit your calculate button. It's right there where the trace button is. We want the maximum, so that's number 4. You can just hit the number 4. What's the first question it asks? Left bound. So move to the left of your maximum. There's my maximum. I'm going to move to the left and hit enter. Then I arrow to the right and get to the right of the maximum and hit enter. When it says guess, I hit enter one more time. And it hits the maximum height at 400. What's the 5? The time. And what's 400? The height. So after 5 seconds, it hits its maximum height of 400. This question did not ask us to do that. I'm just showing you that you can do it. We've answered all of the questions. Yeah. Right. So occasionally, this is good for all of you to hear. Occasionally, the rounding is a little off on these. And I don't know, just like when we did the zeros and it gave you that really weird decimal that was in scientific notation. So if it says 4.9999999, go ahead and say 5. Now, if it says 4.97, then it's probably 4.97. But if it has a whole bunch of 9s and then something else, probably round it to 5. Okay, so we can find all of that on this one right here. Okay, so now we're going to move on to number 2. A model rocket is projected straight upward from the ground level according to the height equation. H equals -16t squared plus 192t, comma, t is greater than 0. All they're saying there is that the time is positive. When it says t is greater than 0, they're just saying time is positive. And it says where h is the height in feet and t is the time in seconds. What is the height of the rocket? At what time is the height of the rocket maximum and what is the height? So I want you, is this what? This is number 3, that's fine. We'll skip on down to number 3. Because I wrote all over number 2. So I want you to do the very same process. I want you to first identify the 2 variables and then highlight everything we need to highlight. So what does H represent? Height. And T is time. Sometimes they will use X and Y instead, so it will be helpful, especially when the variables don't start with the same letter. So I'm going to grab my highlighter, and I'm going to highlight for height first. You can. So a model rocket is projected straight upward from ground level. That's a height. According to the height equation, H equals, I'm going to highlight that H, where H is the height in feet and T is the time in seconds. At what time is the height of the rocket maximum and what is that height? So it's asking me for time and height. And then if I go back and highlight all the stuff that had to do with time, we had our time in the equation. We had that time had to be positive. We know T is the time in seconds. And we know it's asking us at what time.
Wait, there's no height, would we also highlight in the first line, it has height equation?
It depends. If you think it would be helpful for you to highlight it, yes. So here we're looking for the rocket to hit its maximum height. So for all of these word problems, you have to stop and think, what am I looking for? So where does a rocket hit its maximum height? If you're thinking about a parabola, where is that maximum height? At the vertex. So when it's asking for maximum height, I want you to circle that word maximum, and I want you to write vertex. When it's asking for the maximum, it's wanting us to look for the vertex. Now, since this equation is in standard form, h equals negative 16t squared plus 192t, what would c be? What would the value of c be?
0.
0, because it's starting out on the ground. This is one of our ones that finding the vertex takes a little more work. And in order to find the vertex for this, we have to find the axis of symmetry. So the axis of symmetry is that x equals negative b over 2a. But what is our x? What variable is our x? T. So instead of saying x equals, we're going to say t equals. So t equals negative b over 2a, or negative b divided by 2a. So b is positive 192. So we're going to say negative 192 divided by 2 times negative 16. So we have a negative divided by a negative, which is going to give us a positive. Well, that's negative 32, yes. And then negative 192 divided by negative 32, is it 6? Check your calculator. Yeah, 6. Second and quit is how you get out of the graphing screen on your calculator. Second quit. 6, and what are the units? What did we find? This was t, so times, so seconds. So we have a rocket that went up and came back down, and if the axis of symmetry is at 6 seconds, that means it took 6 seconds to reach its maximum height. It will spend another 6 seconds coming back down. But we want to know, so we've answered at what time? 6 seconds.
Would it be faster coming down because it's gravity?
There's several different things in play, and it feels like it should fall faster than it goes up. But think about when it goes up, it's being given some force, and when it comes back down, it's not. So it ends up being the very same amount of time, but in my brain that feels funny. So it makes
And then for
totally
the 6 seconds, now you're like plugging in the height.
So we found the 6. We want to know the height. So we're going to plug 6 seconds back into our equation. So h equals negative 16 times 6 squared plus 192 times 6. What's 192 times 6? 11 something.
1152.
So it ends up being 576 feet, I think. Is that right?
Yeah.
So when you're finished doing your computation, you want to make sure you know what you found. So we found that when we plugged in 6 seconds into the height equation, it was at a height of 576 feet. So now you're going to state your answer in a complete sentence. The rocket hits its maximum height of 576 feet after 6 seconds. That's just one way you could write it. The rocket hits its maximum height of 576 feet at 6 seconds. Or you can say at 6 seconds, the rocket hits its maximum height of 576 feet. Either way.